Alright, let's get this set up. Relations and functions. Hi Sarah. Hi Porter. Hi Lyra. Hi everyone. Hopefully everyone's doing good for our last full week of school here. I have it pretty easy for you guys, so it's mostly going to be just working on stuff that is already, so things that are already out there floating around. That's really what you're doing this week. I am not going to finish the chapter in math that you're on, but that's okay. You'll get all that again next year anyways. You're getting into some pre-algebra stuff, which is more fun. Nope, you just got to listen to me and try not to fall asleep, Porter. It's going to be a grand old time. I am done assigning you new work. I've decided that over the weekend. So whatever work has been assigned, that is what you need to turn in. I would like it by the end of the week, that way you really don't have to do anything next week, but it's up to you. When is science due? Science will be due the 26th. I cannot really extend that because I have to have my grades done. So keep that in mind. And there will be, again, I'm not going to assign anything new. So whatever's outstanding in math and whatever's outstanding in science, that's what needs to get done. That's what you're spending this week working on. In fact, tomorrow, I think, actually, I might not live stream with you until Friday unless someone has specific questions. Then I can do individual things, or I will post it in the classroom and things like that. But today I'm going to throw a bunch of information at you, and whatever sticks, sticks, and we're going to go from there. But functions are fun, so today we are looking at functions. Functions are types or specific relationships. For the past couple days of last week, you were looking at relationships. How does one variable affect another variable? What's the connection between your independent variable and your dependent variable? Functions are specific types of relationships. So if you are following along with our PowerPoint, it does spell it out for you nicely, I think. But first, we need to know what a relationship is. So first, let's talk about a relationship in math, or a relation. A relation is simply a set of ordered pairs. Those are your ordered pairs, again, are your x comma y. Right? You have an x unit, you have a y unit, and so on. Yeah, we can go over work from Friday when I'm done here. I'm just going to give you a bunch of definitions. It's not too difficult, and you're not going to be tested or have to do any work on it. So you have to listen and humor me. So relationship is just, or a relation is just a set of ordered pairs, x and y. And these are things that you can graph on your coordinate plane, if you recall that. Right? You have your x-axis and your y-axis. If I give you a point, you can do it. Important to note that it is a set. So be aware that this means it is just a list. Sets are in brackets, though. So those are the squiggly brackets that I told you not to use unless you're talking about sets. So it would be something that, and this would be like x1, this would be y1, x2, and y2. And it would be a set. So this here is technically a relation. It's a set of ordered pairs. That's all that means. You also have things called domains. Domains are going to be your x values. So it is a set, I should say set of x values. So again, this is another set, so it's a list. So again, it's a list of x values. This also represents your independent variable from Friday. So your domains are your inputs or your independent variables. We can call that input as well. And then you also have ranges. Or I guess just range. And this is your set of y values, or your dependent variable, or your outputs. Input and output will make sense when we talk about a function. But these here are your possible values for your x's, and these here are your possible values for your y's. So depending on what the situation is, you might have this restricted. And if this is restricted, it's going to affect this, because this is your independent variable. It's going to affect your dependent variable. X, Y, Z is also a relation. It's an ordered pair. I mean, you can get into your... We didn't talk about your z-axis. I mean, technically you have a z-axis, which is depth. We didn't talk about that. If you can imagine this being three-dimensional, which I can't draw because I can only draw two-dimensional things. But that would be like an ordered pair for it. I mean, if you're playing Minecraft or something, those are your coordinates, right? X, Y, and Z. So, I mean, and it's a set. So it's a bunch of them. It's not really just one. If it's just one, there might be a relation, but it's not really like useful. It's a set of things, so it has a whole bunch of them as well. And that's our range. So our range is our y values, or it represents our dependent variable, and things like that. So a function is what we really want to talk about. Is a specific type of relation. So it is a type of relation where every x value has exactly one y value. So if you look at the examples that I gave you them in tables. So if I delete this, I gave you them in tables. So if we have an XY table, we have an X and we have a Y. I used f of X, which is the same thing as Y. But we'll call it Y here, right? And you have this table, and it says that 2 goes with 7, 2 goes with 9, and 4 goes with 3. Here, for this to be a relation, it's just a set of ordered pairs. So here we do have a set. I did not get the email either if she's having one. She normally sends me an email, but I didn't get one, Gianna. So this is a set of ordered pairs. We have 2, 7, we have 2, 9, and we have 4, 3. So this is a relation because it's a set of ordered pairs. Right? You can see your ordered pairs coming right out of it, just like that. I'll put commas in there. In this case, it's not a function, though. This is not a function because of this x value here. If I plug in 2 to it, I could get out 7 or I could get 9. I don't know. Right? So in this case, either 7 or 9. I don't know. It's not a function. A function says there can only be one y value or I'm sorry, there can only be one y value for every x. In this case, this x here has two y values. So if x equals 2, I could get y equals 7, or I could get y equals 9. Because you see how 2 goes to 7 and 2 also goes to 9 here. Right? I don't know which one it's going to go to based off of this information. So it's not a function because of that. However, you can get things like you have your x value, you have your y value, you have 2 goes to 7, 3 goes to 7, and 4 goes to 3. This here, again, it's a set of ordered pairs, 2, 7, 3, 7, and 4, 3. This is a function because I know exactly what I'm going to get when I put in my domain. A restricted domain, it is implied that any value will work unless it's restricted. For example, you can go back to your ticket problem, right? Let's say we have a relation between, I forget what the numbers were, but it was like 3 tickets. All right, here, we'll just do 1 ticket. 1 ticket costs $10, right? Here, tickets represent your independent variable. Cost represents your dependent variable, right? 1 ticket costs $10. This domain is technically restricted because I can't buy any number of tickets I want. I can only buy certain amounts of tickets. For example, I cannot buy 3 1/4 tickets, right? That doesn't make sense. You can't buy part of a ticket. Therefore, I'm going to restrict the domain and say, hey, you can't buy fractions of tickets. It also doesn't make sense that I can buy like negative tickets. Unless they're taking returns, I guess you can think of that way. You don't have to write anything down today, Catherine. We're just going to talk. So in this case, we can't buy like -3 tickets. Right? That doesn't make sense. So what I'm going to do is I'm going to restrict my domain and say, hey, you can only buy tickets where x equals like 1, 2, 3, 4, and so on like that. So my domain will be restricted. I don't want numbers between them. In other words, I'm going to put a restriction on it, right? And say, hey, you can't necessarily do all values you could possibly think of. No, you don't have to take notes. You'll get this again next year. In fact, you'll get this again in 8th grade too. Functions are extremely important. And you're not going to be tested this year because I'm just running out of time. So, but this here is a function. It might be the fact some things for 2 equals to 7, 3 will also equal 7. It might happen. Your function is normally a rule too. We can actually get something involved with it. So let's look at a function as an equation, just for the fun of it. I can say that y equals 3x plus 2. Right? In this case, this here would be my function. For every x, I'm only going to get one y value. So if I plug in 1 for x, right, if I say x equals 1, then y is going to equal 3 times 1 plus 2 equals y. Y equals 3 times 1 is 3 plus 2 is 5. Right? I can plug in 2 for x. I can get y equals 3 times 2 plus 2. In that case, I get 6 plus 2 is 8. Sorry. Right? So this here is a function. It's going to do it. You can plug in any value you want for x. I can plug in -3. Right? Y equals 3 times -3 plus 2 gives you -9 plus 2 will give you -7. right? And you can plug in any number you want. In this case, the domain is not restricted. However, some functions are, and I don't know how well you are at, like y equals the square root of x. This would have a restricted domain because you can plug in like 4. Right? If x equals 4, then y equals the square root of 4. And this is going to be strict. This is actually a bad function because we want the positive square root of it. How about that? And in that case, we get positive 2, so x would be positive 2. However, you can't plug in negative 4 for x because we don't. Y equals the square root of negative 4 is not a real number. Right? You can't take square roots of negatives for it to be a real number. So if we plug in negative 4 here, we could get undefined, or it's imaginary. That's the kicker, because not every y is going to have 1x. It's that it only works the one way. So it has to be function every x has exactly 1 y. Right? It does not work the other way around. And that's where I think you tend to get confused on your independent and dependent variables, Eli, is because the ones that go both ways get confusing to you, because y would then show a correlation with x. However, x is still going to be your independent variable. And correlation means there's just a relationship between them. The ones that don't go the other way are pretty easy to tell that, hey, x really isn't probably causing y very well. But you can't prove causation this way. You have to do a lot more math to prove that something causes something else. And you're not ready for that. That's grad school math. That's what I did in statistics for grad school, hypothesis testing. Right? So with that, hopefully that clears up a little bit for you if you're having trouble with independent and dependent variables, but it is going to get into functions. Some of you said they had questions on page, what was it, 288 or something? I don't remember what page we were on. I got to look in the chat here. 228. On page 228. So let me find my book and let's look at page 228 to see what kind of questions we can solve here. So I know Catherine was asking about it, and Kelsey was. So let's look at page 228. Oh, I'll actually delete it. Number one is comparing cost to total. So cost to discount, actually, sorry. Discount. And your discount is dependent upon your cost. So your cost is your independent variable and your dependent variable is dependent upon that. Right? The more you spend, the more you're probably going to save. That's just how life works, because discounts are normally percentages. So like 1% of 100 is a lot more than 1% of, 1. So cost is going to be your independent variable and your discount will be your dependent variable. In that case, you should be noting, what is the relationship, what is the table here? We got cost and discount. And we have 20 to 3, 50 to 7.5, 100 to 15, and 200 to 30. So you should be noting that you're saving 15%. So it's asking for whether it has a common difference or a common ratio. Quotient uses quotient in the book. Quotient, and then it's telling you, and then it's asking for the equation of it, which will be your function in the end here. So here your common difference, does it have a common difference? 3 minus 20 gives me, it is not going to have a common difference. That should be pretty easy to see. So it is a common quotient. Right, again, 3 minus 20 does not equal 7.5 minus 50. You don't really have to do much work to think that one through. That one's pretty clear. It should have a common quotient. So 3 over 20, is that the same thing as 7.5 over 50, which is the same thing as 15 over 100, same thing as 200 over 30. These ones here are probably the easier ones to do. Like this one is 0.15. This one here is also going to be 0.15, I know, because it's just times 2 for both of these, which means your common difference is going to be 0.15. So we do have a common difference of that. So what you're going to do is you're going to take your cost, you're going to multiply it by 0.15, and that is going to give you your discounts. I'm sorry, there's a 1 there. I said it, I just didn't write it. 5. So there you go. That's everything you need to know. We identified which is independent and which is dependent. We identified our common quotient as 0.15, and we made our function. So this here is your function, right? You can put in any cost you want, and it will tell you your discount. So for example, if I had the cost of 3, I would put in 3 here, and I would get a discount of 20. Or I'm sorry, 20, I would get a discount of 3. Sorry. Yeah, that's why it gets recorded. So yeah, you can watch it later. We're just going over homework. And number 2. Number 2, you got lawns mowed versus earned money. If you can deal with my abbreviations. And it's got 3 and 96, 4 and 128, 5 and 16, 0, and 8 and 256. So looking at this, how do you go from 3 to 96? You're obviously not adding the same thing because this would be one-off. I mean, you can sit there and check for a common difference, but you could also just look at it and see that, hey, 96 minus 3 is not going to be the same thing as 128 minus 4. So we do have a common ratio here, quotient. We do have a common quotient here. And what is that? 96 divided by 3, 128 divided by 4, or 160 divided by 5, 256 divided by 8. What do each of these equal? They're all the same thing because, well, there's clearly not a common difference. I think it's 32. So these all equal 32. 32, 32. So what you're going to do is you're going to take your lawns mowed, which we'll just call L, and multiply it by 32, and you will get your earned. So I guess it's going to be 32 times L equals E. So So there's your equation, there's your common difference. This is your independent variable, this is your dependent variable. The amount of lawns owned determine how much money you make. The more lawns you mow, the more money you make. So that's number 2. Number 3 asks you to fill in that table, whatever it is. Okay, let's see. Number of meals. So I got meals up here. I got cost. I got difference. Checking for a common difference here, and then it's checking for a common quotient. So this is just a table that's going to check for them for you. I was doing them off to the side, but you know, hey, is that it tells you 1, 2, 3, 4, and 5. And if you read the problem, I think it tells you the cost of 3 meals. Is that what it is? 3 meals costs $29.97. So 3 meals for $29.97. And that's it. So if I want to know price per meal, I actually do the other way. $29.97 divided by 3 is going to tell me the unit rates, or what one meal costs, and you'll find out that one meal costs $9.99. Then you just multiply it by 2, and you get the next meal, which would be $19.98. Multiply that, or add another 9, multiply this by 3, and you get this one. Multiply this by 4, you'll get this number, which is $39.96. Multiply this by 5, and you will get $49.95. So that should fill in your first row. And then you look for the common difference between them all. So 1 minus this is clearly going to be, well, this minus 1 is going to be $8.99. That minus 2 is going to be $17.98. Minus 3 will be $27.97. Minus 4 would be, that's not 26, it's 26. Sorry. Minus 4 would be $35.96. Minus 5 would be $44.95. And there's clearly not a common difference because they're all different numbers. And if you divide them, you should be getting $9.99, $9.99, $9.99, $9.99, $9.99, because hey, everything's a function of the one meal, right? So you're going to take your meal price. I'm just double checking to make sure I answered number 3. Yeah, just wanted you to complete the table. So that was 3. Number 4 is asking for your independent and dependent variable. So meals is your independent variable and cost is your dependent variable. However many meals you buy is going to determine the cost of what you spend, or how much you spend. And in that case, your function is going to be, we'll call this M and we'll call this C. Your cost is going to equal $9.99 times however many meals you buy. And that would be your equation. So that's 1 through 4. I don't think I asked you to do number 5. For writing an equation when the pattern in the table is common difference versus common quotient. Oh, I don't know if we did 5 or not. 5. If it's a common difference, your equation has adding and subtracting. If it's a common quotient, your equation has multiplication or division, depending on which way you want to write it. Any other questions? If not, again, I'm not assigning anything new. Tomorrow you're just working on whatever you have to work on. Mostly focused on science. I think a lot of you did pretty well keeping up with the math. I appreciate all your work through all this. And I may or may not talk to you again this week. I might talk to you on Friday just to check in to see if anybody has any questions that way. But other than that, you're on your own. Just get the work done that is needed and send it to me. Try your best to put it in the drop boxes in option C. I tend to lose things if you just share it with me or if you email it to me because I get so many emails. You said 3 divided by 20. Would it be 30 divided by 200? Yeah, it should. Sorry. No, I don't have my glove on. I'm not sure. I think I got some things from you, Lyra. Keep an eye on option C. I'm trying to keep it updated. I got some things from you, Lyra. I will try to update it again tomorrow. I'm going to try to update every day. That's what I'm going to be doing. Just keep an eye on it. You guys still have a week to get things in. So if I'm missing it, I will let you know through option C or I'll email you. So if you have further questions, send me an email. But I am not going to be live streaming this week. I'll give you a break from that. Just get the missing work done and in. That is all you need to do. So I will talk with you